JEE Advanced 2025, Paper 1, Physics, Question 7. Here is the setup. A wave generator at point O is connected to string S1 with linear mass density mu. S1 connects to string S2 at junction P, where S2 has density 4 mu. Then S2 connects to string S3 at junction Q, where S3 has density 16 mu. The far end of S3 is fixed to a rigid wall. The wave generated at O is y equals y0 cosine of omega t minus kx. The question asks, which of the following statements about the reflected and transmitted waves at junctions P and Q are correct? Option A, the wave reflected from P is alpha 1 y0 cosine of omega t plus kx plus pi. Option B, the wave transmitted through P is alpha 2 y0 cosine of omega t minus kx. Option C, the wave reflected from Q is alpha 3 y0 cosine of omega t minus kx plus pi. Option D, the wave transmitted through Q is alpha 4 y0 cosine of omega t minus 4 kx. The key concepts here are wave reflection and transmission at a boundary between two strings. When a wave travels from a lighter string to a denser string, the reflected wave undergoes a phase change of pi and reverses direction, so kx becomes plus kx. The transmitted wave continues forward but with a different wave number because the wave speed changes. Wave speed v equals the square root of tension T divided by linear mass density mu. Since tension is the same throughout, if density increases by a factor of n, speed decreases by root n, and the wave number k increases by the same factor root n. Let us analyze option A. The wave reflects from junction P, going from S1 with density mu to S2 with density 4 mu. This is reflection from a denser medium. So the reflected wave gets a phase shift of pi and reverses direction. The reflected wave travels back in S1, so the wave number remains k, but the direction reverses from minus kx to plus kx. Therefore the reflected wave is alpha 1 y0 cosine of omega t plus kx plus pi. This matches option A. Option A is correct. Now option B. The transmitted wave through P enters S2. In S2, the density is 4 mu, so the speed is v2 equals v1 divided by root 4, which is v1 over 2. The wave number in S2 is k2 equals omega over v2 equals to omega over v1, which is to k. So the transmitted wave should have wave number to k, not k. But option B writes cosine of omega t minus kx, using the original wave number k. This is incorrect. Option C. The wave reflected from Q. At Q, the wave in S2 with density 4 mu hits S3 with density 16 mu. Again reflection from a denser medium, so there is a phase shift of pi. The reflected wave travels back in S2, so its direction reverses. The wave in S2 has wave number to k. The reflected wave at Q should have wave number to k, going in the reverse direction, giving plus to kx plus pi. But option C writes cosine of omega t minus kx plus pi, using the wrong wave number k and the wrong sign. Option C is incorrect. Finally option D. The transmitted wave through Q enters S3 with density 16 mu. The speed in S3 is v3 equals v1 divided by root 16, which is v1 over 4. The wave number in S3 is k3 equals omega over v3 equals 4 omega over v1, which equals 4k. The transmitted wave goes forward in S3 with wave number 4k. So the wave is alpha 4 y0 cosine of omega t minus 4 kx. This matches option D perfectly. Option D is correct. The correct answers are option A and option D. Tips for wave reflection and transmission problems. First, always check if the wave goes from a lighter to denser medium or vice versa. Denser medium causes a phase shift of pi. Second, the wave number changes in a new medium. Use k equals omega over v, and v equals root t over mu. Since tension is constant, k scales as the square root of the density ratio. Third, reflected waves reverse direction. If the incident wave has minus kx, the reflected wave has plus kx, with the appropriate wave number for that medium. Like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.